Bioprinting is an innovative technology that enables the creation of three-dimensional, living tissues using specialized printers and biological materials. Extended reality, or XR, is an umbrella term that encompasses virtual reality, augmented reality, and mixed reality, blending digital and physical environments. Both bioprinting and extended reality are at the forefront of technological advancement, offering new possibilities in fields like medicine, engineering, and education. Their significance lies in their potential to revolutionize how we approach complex challenges, from fabricating organs to enhancing interactive experiences. Bioprinting is an innovative technology that enables the creation of three-dimensional living structures by precisely layering cells and biomaterials. The process typically involves using specialized printers to deposit bioinks, which are mixtures of living cells and supportive substances, in a controlled manner. Common materials used include hydrogels, collagen, and various types of stem cells, each chosen for their compatibility with human tissues. In healthcare and research, bioprinting is already making significant impacts, from fabricating tissue models for drug testing to developing skin grafts and cartilage implants. These advancements are paving the way for more personalized and effective medical treatments in the future. Extended reality, or XR, is an umbrella term that encompasses technologies like virtual reality, augmented reality, and mixed reality. Virtual reality immerses users in a fully digital environment, often used for medical training simulations where students can practice procedures without risk. Augmented reality overlays digital information onto the real world, assisting surgeons with real-time data during operations or helping researchers visualize complex molecular structures. Mixed reality blends physical and digital elements, enabling interactive experiences such as collaborative design in scientific research. Together, these technologies are transforming how science and medicine are taught, practiced, and advanced. Extended reality is reshaping the landscape of bioprinting by enhancing every stage of the workflow. Through immersive visualization, researchers and engineers can interact with complex tissue designs in 3 dimensions, allowing for more precise planning and modification. Simulation tools powered by extended reality enable users to test and refine bioprinting processes in a virtual environment, reducing errors and material waste. Additionally, training programs that utilize these technologies provide hands-on experience in a risk-free setting, accelerating skill development and improving overall outcomes in bioprinting applications. Recent case studies demonstrate the transformative potential of combining bioprinting with extended reality technologies. In medical education, students have benefited from interactive, 3D printed anatomical models enhanced by augmented reality overlays, allowing for a deeper understanding of complex structures. Surgical teams have used virtual reality simulations alongside patient-specific bioprinted tissues to rehearse intricate procedures, improving precision and outcomes. In tissue engineering, researchers have visualized and manipulated bioprinted constructs in real time using extended reality, streamlining the design and evaluation process. These integrations are paving the way for more personalized, effective, and immersive experiences across healthcare disciplines. Integrating bioprinting with extended reality presents a range of challenges and limitations. Technical hurdles include ensuring precise alignment between digital models and physical prints, as well as maintaining the viability of living cells during the process. There are also significant ethical considerations, such as concerns over patient privacy, data security, and the potential for misuse of bioprinted tissues. Additionally, regulatory frameworks have yet to fully address the complexities introduced by these emerging technologies. Careful oversight and ongoing dialogue are essential to navigate these issues responsibly. Looking ahead, the convergence of bioprinting and extended reality holds immense promise for the future of healthcare. As these technologies evolve, we can anticipate more precise, personalized medical treatments and enhanced surgical planning through immersive visualization tools. Bioprinting may benefit from real-time feedback and simulation, allowing for the creation of complex tissues with greater accuracy. This synergy could accelerate research, improve patient outcomes, and make advanced therapies more accessible. Ultimately, the integration of bioprinting and extended reality is poised to transform both clinical practice and medical education in profound ways.